So this is your lab number 5. In lab number 5, we studied about USRP. So this is a device by which we will send our signal from lab view, and then we will receive our signal passing through this, and then we will receive it in PC back in lab view. Okay, so for this we have to design a transmitter, and then we have to design a receiver. Okay, then we will use cables to connect from here, and then there will be another device. We will take this cable, we will connect here, and to the other device also here. And then we can connect it with antenna also, one antenna here, one antenna with other device. Okay. So we go here. So how we design transmitter and receiver? Okay, for that the main USRP functions are open, configure, read, and write. So you have transmitter model. So first you have open block, then configure block, then read and write, and close. In read and write we will provide our signal. Okay, so this is the model of the transmitter. Here we have this open block, then configure block, then read and write block, and then terminating the session block. So all the information about what these blocks are doing. So this block initiates the transmitter session, and also it controls the device's names to inform lab view of USRP, because here you have your device name. Okay, so this device name you will check which device is connected to your computer. So you will select that device. So this has two functions. It initiates transmitter session, and then also it has device names, okay, to inform lab view of the USRP ID. Then this configure block. So this is used to set parameter values in USRP. How? It has IQ rate, it has carrier frequency, gain, and active antenna. So we set the parameter values using this block. Okay. Then writing here, write data block. So this sends the base bias signal to USRP for transmission. So we have our signal. We will provide our signal here, and then it will transmit our signal to USRP for transmission. Then this block, it will terminate the operation of the transmitter. Okay, so you should know what these blocks are doing. Then we have the model of our receiver. So we have RX block, we have again configure block, then initiate block, then writing, and then terminating. So all the blocks. So this block will, so first this block will initiate the session, then this block here we configure the parameters, and here we initiate, it takes values and store in the buffer. This will take values and then it will store in the buffer. Then this block, it takes the values from the buffer and go to the PC. Okay, so next, this is used for acquisition of data. Once the, so the data acquisition will take place in this block after the when the loop session will end. So this is while loop. So in LabVIEW, how we can design our transmitter? So you go here, hardware interface, you have NI USRP, then transmitter. So you press Control key, and then you select all of them, and you drag them here. So 1, 2, 3, 4. Okay, and then you can arrange them like this. Then this configure block, then this block, then this block. So you go here, you bring while loop, you put while loop here. Okay, so for this, if you right click, you can click create control. So here you can give the device name. Then you connect error with error like this. So first step is to connection of error and the top button. So yes, and then also you have to select this here. Okay. Then after that, this is the configure block. Here we set all the parameters. Right click, create control. Then right click, create control. Then right click, create control. Then here you will choose create indicator. Then here again you choose create indicator. Here also you choose create indicator. Okay, you can put it here. Then after that, how you bring this block? So you go here. data types, then you go to Boolean, and then you bring this OR here. And what you do is you delete this one, and then one block you will connect here, one input, and another input here, and then you will connect it with stop. Okay. So this is very simple model, and then here how you bring this data, you click here, and then you bring this. Okay, you bring constant. So this here. Okay, and then from here you bring timeout. Okay, so this is a very simple model for designing your transmitter. So all the blocks are here, how you bring them. Okay, then you can arrange it like this. Okay, so you have 4 blocks. Remember, you should have 4 blocks for the transmitter, and then they should be connected like this. Okay, then for the receiver model, we have we go here. We go to hardware, we go to NI USRP, and we go to receiver. We press control, and then we bring these blocks. Okay, so these are 2, so we delete one. So what is the first step? Connect this. Then you connect this here. Then you connect this here. Then you connect this here. Okay, and then error with error. Okay, so after that you need a while loop for this. You can go here, you bring a while loop for this. Okay, same. And rest of the things are same like transmitter design. You will just bring here, you bring device name. So you configure this block, you just take inputs. And okay, this block is different. So we go to here, receiver. We bring this block. Okay, so this is the correct block. So I will provide you with the design of the transmitter, but you should know it, how you can design it, okay? Receiver and transmitter. Then here at the output, you just bring here data like this, and timeout, and this block, I already told you, you go to data types, then Boolean, and then from here you bring this block. Okay, so just you make the connections, and then the model is ready. Okay. Okay, next. So we are done until here. Okay. So then this is about lab number 5. Now lab number 6 is about transmission. How we can we have prepared our model for transmitter and receiver. Now after that we have to connect the wires and then make the transmission. But how we can do it? So we have to add these components to our model. Okay, this is the signal. This is the time domain signal graph. This is the Fourier Fourier transform of our time domain signal. Okay, so what we do is we go here. Okay, so simple. We will go to analysis, generation. So pattern generator, and then we will just select sine wave from here, or we can just take this block, wave generator. Simple. Okay, so with this we have amplitude. I will provide you with the amplitude of the signal. Okay, and then here the samples. Okay, then what we have to do, this block, we go to data types, we go to waveform, then analog waveform, and then waveform properties. Okay, here. So we connect this here, okay, and then this block from Y goes here, okay. If I copy, so this Y goes here. So I have to choose for this because I didn't send any signal, so it gives error. Anyway, you will connect this Y with this button, second button. Okay, then after that this is already done, and then you have to bring this Fourier transform spectrum. So how you bring it? You go to analysis, signal processing, then measurement, and then effective spectrum. Okay, and then for this and this, you go to panel view, you bring graphs from here, 1 and 2, you put them here, you go back to diagram view. This I will delete, and then you will connect them here. Okay, so rest of the things are same, only these are a few changes which you have to do. Okay, so this is the model of the transmitter, only you will change this. Okay, and then you will connect this here. Then you go to panel view, and then you arrange your components like this. And then from here you will select, when you will connect USRP, you will select your device name from here. If it is transmitter, so you will select transmitter. Here you have to write TX1. Okay. And here this is the signal, which is defined here. Frequency, amplitude, and samples. So this will be provided. Then you will run it. So now this is so let's choose. Okay, then carrier frequency is 2 gigahertz. Then gain is 0. Then amplitude is 1. Frequency is 100, and so the samples should be same as the IQ rate 200. Okay, so let's see. Okay, now I can choose 0.01. So now you see here, or I can choose 10. So it will be very high. So 0.01. Okay, so this is my time domain signal, and this also I can, because frequency is 100, so we can choose 200 so that we can see the frequency. Okay, make it 1000. 1000. Now you see frequency at 200, signal frequency at 200, and this is our signal. Okay, so for the receiver, when you are done with this, when you select your device name, you will run it here, and before that you will connect your USRP with the wires. Okay, so this is lab experiment number 5. So if you go down here, how you bring these blocks, its information is written here. Please go through this. And yes, here you will connect with wire, and here also with wire, and all the blocks, how you bring them, information is here. So after that, when you connect your USRP with wire, you go to lab view, you go to transmitter, and then you select from here your device, and these values I will provide you. Okay, so if you go to your here, you see all these values I provided here. So carrier frequency 2 gigahertz, IQ rate 200. So this I have already provided, and also for the signal. Okay, so then when you have connected your device with the wire, after that you will run it. Okay, when you will run it, you will see the signal. Okay, so then you will go to receiver, and in the receiver you have to make these changes. You have to bring this waveform properties from here, waveform analog, and then waveform properties. Okay, then this block to generate waveform. So you go here, so the data types, waveform, and then build waveform. Okay, so you connect this here, and then you connect here FFT, and then this will give you FFT. This is your original signal. So for the panel, you have to just select your device name, which will be the receiver. Okay, and then here it will be RX1. Okay, it should be capital RX1. Then you will just run it. Okay, and then you will receive your this signal through USRP here. Okay, so this is all about lab number 5. So these values I will provide you, and you should remember the model, which changes you have to do. So, and you should receive your signal like this. Then, so this is the connection of USRP with the antenna. So you will remove wire, you connect with antenna, and then you can do the same steps. You go to transmitter, you put these values. The values are here. You put these values for transmitter, these values for receiver, and just run both of them. So this is all about your lab number 5.